it's Mrs. Pound. Today's video is going to be just a little bit different because it's going to be more of a how-to video. So I don't have slides. I'm going to show you how to do electron dot diagrams. So I'm going to switch my camera over and let's get started. So have a piece of notebook paper out and just write what I write. So electron dot diagrams. The important thing to remember about electron diagrams is that the group number gives us the number of valence electrons. We're going to be putting the number of valence electrons, and remember we're after an octet, so the most we'll have is 8. So the group number gives us the number of valence electrons. And what I'm going to do is I'm going to go through all of the elements in period 1, and we're going to do an electron dot diagram for them. So this is period 1. Remember, periods are the row. Oh, excuse me. I'm going to do period 2. I don't want to do period 1. I'm going to do period 2 because that will give us more of a variety. Remember, the periods are these numbers here, so we're going to go across this way. And so our first one is in group 1, and that is lithium. So group 1A, or sometimes we just call this group 1, we have lithium. Lithium has 1 valence electron because it's in group 1. Okay? So 1 valence electron. And from now on, I'm going to just abbreviate that as VE, okay, for valence electron. So because lithium has 1 valence electron, we just put 1 electron off to the right for it here. The rule is you just put valence electrons around each side and until you have 4, and then you go around again. So for group 2A, or 2, we have beryllium. Beryllium, because it's in group 2, has 2 valence electrons. See how that worked? Group 2, 2 valence electrons. So beryllium, we just start out here and we give it 2 electrons. 1 here, 1 here. Then we go to group 3A, or 13. We're going to skip the transition metals in here, and we're going to go over here because it's not quite as clear cut for these guys, okay? So we're going over here. Now, these have 3 valence electrons, and the rule here, you go, if you're using the Roman numerals, it's just the Roman numeral 3. If you're going by the 13, you just drop the 1 off. Okay, we ignore the 1 and it's 3. So that is boron. And so we go with boron. That has 3 valence electrons, 1, 2, 3 around it. Go to group 4A, or 14. That is carbon. We have 4 valence electrons, so 1, 2, 3, 4, 1 on each side. We have 4 sides, it's like a square around it. We put 1 on each side. Then we go to group 5A, or 15. Guess how many valence electrons nitrogen has? 5. So nitrogen has 5 valence electrons. 1, 2, 3, 4, 5 for nitrogen. Going on to group 6A or 16. That is oxygen. We have 6 valence electrons, so 1, 2, 3, 4. We start over again, 5, 6. So that's oxygen. Group 7A or 17. That is fluorine. Whoops, right here, fluorine. 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. Okay. Oh, and I'm out of room here, but I want to flip on to the back for group 18. Maybe you have room still. I have a reason for flipping onto the back. So group 8A or 18, these are our noble gases. We have neon here. Neon has 8 valence electrons, so 1, 2, 3, 4, 5, 6, 7, 8, all paired around there. Now remember, neon, very unreactive because it has its octet. It's happy, it has a full valence shell of 8 electrons. Going back here, we said groups 1 and 2 are very reactive. They're going to give up their electrons. Boron also. Basically, anything less than 4 will give up electrons. So these guys like to lose electrons. Carbon tends to share them more. These guys here, because they're over 4, will tend to gain electrons. So if they lose electrons, these guys tend to become what we call anions, which are positive, or excuse me, cations, which are positive. These guys tend to gain electrons and become anions that are negative. And so that's what happens there with them. Now what I want you to do is I want you to do the same thing for all of the elements in period 3. So that is starting with sodium. Okay, go across that row and do the electron dot diagrams, and we'll check that in class later.